Let's solve this integral.
The indefinite integral of dx over the square root of 25x squared plus 4 can be solved using trigonometric substitution. The rule for trig sub is when you have an integral with x squared plus a squared, we'll substitute our x as a tangent theta. We're going to start by isolating our x squared to be able to determine what our a value is. We'll do this by dividing both x squared and 4 by 25. We'll take the 25 out of the square root, which will leave us with the integral of dx over 5 times the square root of x squared plus 4 over 25. Now we have our integral in x squared plus a squared equals a tangent theta form. Our a value is 2/5, so our x is going to be equal to 2/5 tangent theta, and our dx is the derivative of x, making it 2/5 secant squared theta d theta. Now that we've defined x and dx in terms of theta, we'll go ahead and rewrite our entire integral in terms of theta. So wherever we see a dx, we'll plug in our dx, and wherever we see an x, we'll plug in our x in terms of theta. This will leave us with the integral of 2/5 secant squared theta d theta over 5 times the square root of 4/25 tangent squared theta plus 4/25. When solving integrals using trigonometric substitution, recognizing trigonometric identities is key. We can recognize that by factoring out a 4/25, it'll leave us with tangent squared theta plus 1, which is equal to secant squared theta. Now that we've rewritten our trigonometric identities, we'll focus on simplifying our integral until we're able to do something with it. We can cross out one of the secants in the numerator and get rid of the secant theta in the denominator, which will leave us with 1/5 times the integral of secant theta d theta, which is an integral that has a known solution. The solution to this will leave us with 1/5 times the natural log of the absolute value of secant theta plus tangent theta plus c. So we have our answer in terms of theta. Now we need to get back to terms of x because we started with our integral in terms of x. We'll do this by using a right triangle and using SOHCAHTOA. We already know that x equals 2/5 tangent theta, but if we want to isolate tangent theta, it'll leave us with 5x over 2 equals tangent theta. Tangent theta is equal to opposite over adjacent, so we'll put our 5x on the side opposite of our theta on the right triangle, and our 2 on the side adjacent to our theta. We'll now use SOHCAHTOA and their reciprocals to solve for the identities of secant theta and tangent theta to plug into our solution. Secant theta is hypotenuse over adjacent, which will give us the square root of 25x squared plus 4 over 2, and tangent theta we already know is 5x over 2. When we simplify our math, using the rules for natural logs, this will leave us with 1/5 times the natural log of the square root of 25x squared plus 4 plus 5x plus c as our final answer.